First slide, please. Okay, so when you look at this graph, I'm so sorry again. What do you think the velocity and the distance represent? It's like, what velocity is it measuring? The velocity of what? Can anyone answer in the chat? Not yet. It's measuring the velocity of what? Like what is the velocity representing? Okay. So I see a few answers in the chat. Okay. So I think Xiao got it right. It's kind of the speed of other galaxies moving away from Earth. Acceleration is, I guess you could say acceleration, but it's mostly representing the velocity and distance of different galaxies from Earth. So if you look at the graph, can you tell the correlation? Can you tell the correlation between them? Like, positive correlation. Yes. Okay. Yes. So if it's further, it will move faster, right? So, what this means is that the galaxy is actually expanding. So you know how the Big Bang Theory said that everything kind of like starts at one point and everything moves out. So it's kind of like that. Can you go to the next slide, please? Okay, so what analogy I'd use to describe it is kind of like raisins on a piece of like a bread that's baking. So as you can see, the raisin on the right has a distance of like 5 cm at first, 10 cm at first, but it expands to 20 cm, and the one on the left from 5 to 10. So they both double, but the one on the right still moves further. So it's kind of like that. You guys get it, right? W's in the chat? W's in the chat? Okay. Um, yeah, you guys get it right? Yes. Okay. Okay, so can you go to the next slide? Okay. Okay. So going back to the graph, next slide, please. Sanamkran. Okay. So if you look at the graph, it's a linear graph, right? So the velocity is on the y-axis and the distance is on the x-axis. So we can write an equation to relate these two by the y equals mx plus c. But since c is 0, it's just y equals mx. So can you tell me what k is in this like scenario? It's the gradient, right? So if it's the gradient, do you know what constant is given to the value of the gradient for this graph? Like, what's the name of? Yeah. Hubble's constant. Yes. Okay. Yes, it's the Hubble's constant. So next. So yes, k is the Hubble's constant, and if you equate Hubble's constant times distance to distance over time, since they both represent velocity, you can get the age of the universe by getting the inverse of the Hubble constant. You guys get it? You just have to rearrange the formula. Because since the start of the universe, right, the amount of time it takes for that galaxy to reach that point is the time, right? So if you want the age of the galaxy, you have to kind of do that. You have to like inverse the h just by rearranging it. You get it right. Just like cancel out the d. You guys understand? W's in the chat. Yes, I am nervous, bro. What are you talking? Okay. The age of the universe. Okay. So the age of the universe is the time it takes for the galaxy to reach that distance, right? So that's velocity equals distance over time. To get time, you just equate the two equations and then you find time. Do you get it? Oh, K is okay. K is actually okay. K, I just used it as a replacement for m because y equals mx plus c. So then I'm like changing m to k. Get it? It's like constant. Okay, I'm just gonna assume you guys get it. Okay. Next. Next, please. Next, please. Next, please. Oh, too much. Too much. Too much. Go back, please. Please. Okay. Go back again. Go back again. Okay. Okay. So let's can you answer some of these questions? Can I give you guys is 5 minutes enough for you to answer these? Yes, I'm giving you time. I'll give you guys 5 minutes to finish these questions and then I'll discuss it, okay? Timer starts now. Okay, yeah, maybe it's overkill. Just give some people time, I guess. What are you having problems with? It's okay, I'll discuss it later. So if you don't understand it now, you can just chill and I'll tell you how to solve it later. Is that okay? Okay. Um, okay, how about I just like discuss it now? Would you guys want me to discuss it now? Okay, I'll discuss it now since someone really basically did the answer. Okay. I can't really present my screen. Wait, can I just like turn on my camera? Just show you what I'm showing on my computer. Okay, wait, give me 1 second. Okay, wait. How do I flip my camera? I'm like an unk right now. I'm so sorry. How do I turn my camera?
Do you need help?
Okay.
Oh my god.
Wait, no.
Girl, wait. Put it like that.
Wait, it's so embarrassing. We should gonna try.
Wait, you off it first.
Okay, you know
Can't you
what?
share your screen?
Hmm?
Can't you share your screen?
I can't share my screen. It's not working. Okay, you know what? I'll just like face my camera. in front like this, low key. Okay. Like, can you guys see my computer? Wait, oh my gosh. Okay, so assuming you guys can see my camera. Okay, let's start. Okay. 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 So the get it? Wait, guys. Before we discuss it, can I please have the chance to explain? So sorry. Okay, so yeah, so if you want to find the distance, you have to arrange the equation. So distance is equals to velocity over Hubble's constant. Guys, get it? Okay, I'm gonna assume we get it. Okay. Okay. So just actually, you just need to plug it into the to the calculator because and you get the answer in distance. So it's just to clarify, it's 1.3 times 10 to the power of 7 over 2.2 times 10 to the power of negative 18. Velocity times Hubble's constant. No. Because if you, okay, V equals Hubble's constant times distance, right? So if you want distance, you have to divide both sides by Hubble's constant to isolate D. K, okay. Actually, K just means Hubble's constant. I just used it as a placeholder for grade. So, do you have any problem with it? Does anyone have problems with it? So I think you should get, if I'm not wrong, it should be 5.94 or something times 10 to the power something. Something like that. 5.9 times 10 to the power of 24. Because it's velocity divided by Hubble's constant. No. You rearrange to find D because it's asking you for distance. Elijah, sure, later after you can ask. Yes, it's solving for distance because the question is asking for distance. So you divide both sides by Hubble's constant. You should get it. Yo, why is Frenchie trying to take my job?
Who's that? Girl.
Okay, yeah. Yeah, it's Supreme. Yeah, Supreme, you're right. Yes. I mean, I can't really read that. Low-key. Okay, so I'll move on to the next one. Okay. Yes, everyone get it? Does Rapture get it? Vanessa guy, do you get it? Rapture, guys. I mean Rapture. So sorry. Rapture, do you get it? Okay. So next question, yeah. Calculate an estimate for the age of the universe. So basically, you just 1 divided by 2.2 times 10 to the power of negative 18, because the inverse of Hubble's constant is the age of the universe. Understand? You should get about 14 billion. I'm pretty sure.
Oh, I'm so sorry for you.
Yeah, inverse of Hubble constant. Yes. Okay. So I would share my screen as well, but so you know from the Big Bang, right? The Big Bang to now, that's the type. Unit 1 mechanics. I can do it next time if you guys want. But right now I'm doing space physics. Okay, so anyways, you inverse it by just 1 divided by 2.2 times 10 to the power of negative 18. because you see, if you like just now in the slides, sorry, Junior, can you go back 2 slides or like 1 slide? Yeah, okay. As you can see, Hubble's constant times distance is equals to distance over time, because both sides equal to velocity. So you equate both of them, and then you can like cancel out distance. So basically, 1 over Hubble constant is time. Get it? Okay. So you should get, I think, 14 billion, something like that. 14 with some change. Yeah. 4.5. I think it should be 14545454. Because when I did it, uh I just did 1 divided by 2.2 times 10 to the power of negative 18. A billion. It's like, yeah. So it's you just invert the Hubble's constant. The formula is just 1 over Hubble's constant. Actually, you know what? I'll like do a Q&A later. You guys can ask any like questions that you have or any problems, and I can solve it. I can help you solve it because I need to move on to the next question. Is that okay? W's in the chat for okay. Yes, that's how you invert it. Okay, then I'll move on to the next one. There's actually just more questions for you to understand. Next, please. Next, please. Junior, next. Junior, next. Yo. Junior. Too much. Okay, one more back. I think one more back. Yeah, okay. So this one is very easy. I'll give you 2 minutes. Yeah. 2 minutes to solve this, okay? Yes, you find the gradient. If it was yeah, because you can just find the what you call it, the gradient, but that also works to find the formula. But then you have to, I mean, it's the same way, so yeah.
No, maybe they're like newcomers and they just want to.
Okay, so I'll discuss it now. As I said before, the Hubble's constant is actually just the gradient of speed and distance graph for a galaxy for Hubble's law. But you guys can use the formula too. But by using the formula, it's the same. It's the same as using this, because the only way you can do it is by finding points on the graph. So it's the same. But what I usually do is find a point where the the line kind of touches perfectly on the corner of the box, so it's easier to do. For me, I used 20 and on the x-axis and 0.5 on the y-axis because that's like where they meet. So basically, x equals to 20. So you should get 0.025 for your gradient. Does everyone get 0.025 for your gradient? Okay. So if you get that's the gradient, right? But you still have to like kind of wait, what was I gonna say? Wait, give me 1 second. Oh yeah. You still have to put the 2 point. Wait, what was I gonna say? Oh my gosh, wait. Sorry, give me 1 second to clear. Okay, yes. Okay, I got it. Okay, so 0.025 is the gradient. But then you have to also take into account the units of both x's. So for the one, so it's 10 to the power of 4 kilometers per second divided by 10 to the power of 20. So basically you have to, that's just basically the answer. You have to like, not really just basically the answer, you like have to multiply it. But because for units purposes, you have to 10 to the power of 4 divided by 10 to the power of 20. You guys get it? I wish I could present my screen right now. Yeah. To simplify, you basically just have to like, power rules. So you have to 4 minus 20, which is negative 16. So it's 10 to the power of negative 16 for, okay. So first of all, you need to find the gradient of the graph. Okay. So you find the gradient and then you find the, you just find the gradient. I chose 20 and 0.5 because they are easy points, easy to calculate. So then you should get 0.5 over 20, which is 0.025. Can you get that as a gradient? Okay, I'm gonna assume you got that as a gradient. So once you get the gradient right, you get 0.025. But then you still have to take into consideration the 10 to the power of the unit. So it's actually 10 to the power of 4 divided by 10 to the power of 20, like this. So 10 to the power of 4 over 10 to the power of 20 should be 4 minus, for the power for 10, is 4 minus 20. So 0.025 times 10 to the power of negative 16. That should be your answer. To the power of negative 16. Because 4 minus 20. Oh, yeah. Oh, wait, yes. I'm so sorry. Yeah, correct. So can everyone get the answer? Can I move on? Is it okay if I move on? Okay. So, okay. Yeah. Yes. No. 10 to the power of 14. Because you get 0.025 times 10 to the power of negative 16. So then if you multiply the 0.025 to 2.5, it's you should take you should add the yeah. Do you understand? Okay. So okay, I'll just type it in the chat. Okay, this is your first answer, right? But you want the 2.5 to be in front because that's like the standard method of answering. So you multiply by what's FM26? Okay, I'm just gonna okay. So you multiply by 100. So then you should get I'm sorry, I don't take the February March series, guys. What? Wait, I don't even know what you're talking about. Okay. You guys get it? You multiply by 100 for both. Can I move on? Is it okay? Do you get it, David? Okay. David, if you still have problems, you can like text me. So after the power 18, you multiply by 100. It's power of negative 18. So then if you multiply 10 to the power of negative 18 by 100, it should be 10. Wait, not 18, sorry. It's 16. So 10 to the power of negative 16, you multiply by 100, it should be 10 to the power of negative 14. Can you use power rule all of you? Okay. So I think for the sake of time, I'll just you can Junior, can you show the next question? Okay, you guys can screenshot this and try to solve it later. You guys can try to solve it later, but I'm gonna move on to the next topic. Okay? Okay, next please. Okay, finally, Doppler effect. So does anyone have an idea of what the Doppler effect is? Okay, I'll explain then. I'm supposed to explain anyways. So the Doppler effect is when the wavelength of a sound wave or a light wave changes due to relative motion of the source of the wave. So if you look at the slides, the light is moving from the guy to the girl. So since the distance between the waves changes as it moves, the wavelength relative to each observer changes as well. Do you guys understand? So when the wavelength gets longer, it gets redder, right? And when it gets shorter, it gets bluer because more violet, because that's how the electromagnetic spectrum works. You understand? Yes, it is just like perception based. It's based on the observer's view. So the actual wavelength doesn't change. Like the actual source, like it doesn't actually change its wavelength like inherently. It's just that it's observed differently based on the observer. Like based on whether it's coming it's coming closer to you or it's moving away from you. It seems like happens because let's say the light is moving, okay? You see the light moving and it moves to the right, but also the light coming out from it is still coming out at the same wavelength. But then since it's moving away from you, the distance between each time the light comes out is longer. Get it? It's like the sound like when a car moves past you. and then it's kind of like getting higher when it's moving towards you, and then away from you it's getting lower. It's the same effect. Okay, next, please. So this is called. It happens because. Okay, I'll answer your questions later. I'll just have to kind of move on to the next slide. Okay. So if you can see look at the spectrum, these are called absorption spectrums. Okay. So it shows the elements that are absorbed by the planet or star or whatever that you're observing. Okay, so let's say at rest is in the middle, and then if it's moving towards you, the wavelength gets shorter, right? So it's called blue shift. So if you can see, look at the spectrum on top, it's shifted literally to the left. Like the absorption spectrum is like shifted to the left. So then you can tell that the planet is moving away from you. And vice versa on the bottom, it's shifting to the right, so it's redshift. Actually, in the exam, they might kind of trick you by putting the spectrum like flipping the direction. So the red is on the left and blue is on the right. But just note that if it's moving towards you, it's blue shifted, so it moves to the blue. And if it's further away from you, yes, you can determine the star's movement by just seeing the absorption or emission spectrum. It's actually quite interesting. You can tell whether it's rotating or not. Okay, next slide. Okay, so just answer these in the chat. Give you like 20 seconds. A star's color determines how hot it is. Yes, but then that's like the color of the star. This is like the color of the star, like the color of the star you observe versus the actual color of the star. The actual color of the star is what determines how hot it is. Yeah, color of the observed compared to the color of the actual star. So if it is redder to you, it means it's moving away from you. Technically the temperature determines the color of the star, not the other way around. But like, yeah. Can you guys answer the question in the chat? What is red? How is the observed light different? Okay, so I'm just gonna answer then. Okay, so in the question it says it's moving away, right? So it's redshifted. Yes, it's redshifted. But you have to explain what redshifted is. Like, what does redshifted mean? Yeah, you can say the stretching of the wavelength, or you can say the wavelength elongates. Yes, increase of the wavelength. Okay, so the second question, state the quantity that the astronomers use to determine the speed at which the galaxy is moving away. So do you guys know the answer? It's basically just like redshift. Okay, so just redshift, okay? Hubble's constant does not determine the speed at which, because technically the Hubble's constant it applies for all galaxies moving at all speeds. So you can't really say like. You understand? You understand? Away from the starting point. Okay, so no, you can't really determine the velocity with the Hubble's constant itself, because like, okay, as I said, the Hubble's constant applies for all galaxies. So like, if you just have one, you can't really tell the speed of the galaxy by that. And also like the constant is measured after the velocity was measured. So you can't really like flip it, kind of. Yeah, I guess. Okay. Can I move on? Yeah, redshift you can because it's relative to Earth. Okay, I'll move on then. Next. Okay, I think you guys already know this, so I'll just skip this. Next. Okay, so the spectrum on the top is the galaxy at rest. For A and B, can you tell me whether A is the galaxy is moving away or towards, and the same for B? Yes, the quantity is redshift. Yes, A is redshift and B is blue shift. Correct. So the gaps actually mean like it's telling you what elements that the planet or the star absorbs. So it's called an absorption spectrum because it tells you what elements it absorbs. Get it? Okay, so spectrum is telling you like for example the sun. Okay, so let's say right a planet absorbs hydrogen, and hydrogen releases like the a light a wave a light kind of light, yeah, that of a different like wavelength. So by telling you what elements the planet absorbs, you can tell what planet it is. You get it? Yeah, yes, you can tell the composition. So like one planet may have a few different absorption lines of different elements. So by that you can tell the composition of the planet. But that's not like for this topic lah. Did I just say long? Holy shit. Okay. You can determine if it's redshift or blue shift because when they're absorbing it, right? When they're absorbing it, the wavelength is still moving. Okay, the planet itself is still moving. So if you can tell that the lines are the same pattern of lines, but then they're shifted to the red side or to the blue side, then you can tell whether it's redshifted or blue shifted because elements still like um, emit light, not like radiation. Yes, correct. So you guys all understand? Can I move on? Okay, so I'm gonna cover gravity really fast and then I'll do a Q&A, okay? You can ask me later. Okay, I think all of you know gravity, right? So, okay, I'll just speed run this. Gravity, let's say the astronaut is in between two planets of identical mass. So, if the distance and the mass of, if the distance between the planet and the astronaut are the same for both planets, which planet has the stronger force of gravity? Okay, so let's say left side is planet A and right side is planet B, and the astronaut is equidistant from both. Can you guys tell me which planet has a higher gravitational force? I'll give 5 seconds right now. 5, 4, 3, 2, 1. Okay, so the answer is they're the same. So basically, the force is the same. So therefore, it won't. Assuming there are no other forces acting on the astronaut, the force is the same. So you just low-key just stay there. Yes. Okay, next. Okay, so let's say the mass of the right one is more, then the force of gravity due to that planet is more. Okay, next. I'm gonna assume you guys all understand this. Yeah. Next. If it's further away, then the gravitational force of that planet which is further away is smaller. Okay? Okay. Okay. Next. Yes, this is just gravity. I think it's just like low-key intuitive. Okay, so look at the formula. So you can see that the mass is directly proportional to the force, right? And then the masses of both bodies is directionally proportional to the force. And then the distance between the object centers are inversely proportional. So if the distance is higher, the force is smaller. Okay. So let me ask you just one question. Let's say we take the frame of reference of the astronaut. Can you tell me what is the acceleration due to the force? No. The acceleration of the astronaut due to the force of that planet, of the Earth. That one planet. It's just one planet. It's 9.8. 9.8 is for on Earth. But let's say he's in space. Can you like tell me the variables that are like make up the acceleration? Uh yes, but okay. Yes, that's correct. But also I would say it's gravitational force times the mass of the planet divided by the radius squared. Because F equals ma, right? So if we're taking the frame of reference of the okay, I'll start from the start. Okay, I'll just go from the start. Let's say we're taking the frame of reference of the astronaut, right? So then we are taking the mass F equals ma. So you take the mass of the astronaut, which is m. So everything other than that in the formula is equals to acceleration. So it should be g m1 over r squared. Get it? Actually, it's okay if you don't get it. I'm pretty sure they won't ask you this. It's just for conceptualization. So let's say, of course, uh, um, F equals ma, where a is 9.8. It's that is for when you're on Earth. But then once you're out of like in space, it's different. It's kind of different. It gets smaller. Like 9.8, it gets lesser. The acceleration decreases. So you can't really use 9.8 in space, for sure. For when on Earth, when in space. What are you talking about? Okay, so the answer is g m1 over r squared. I'm so sorry, guys. I'm so sorry. I'm just a very cheerful person. Okay. This is the acceleration, where m2 is the mass of the. Yes, so it depends on your frame of reference. If your frame of reference is the Earth, then it's gm2 over r squared. Okay, last question relating to gravity. Is the force of gravity on the Earth due to the human higher or lower than the force of gravity due to the due to oh my gosh, due to the planet on the human? Sorry. Okay. Force of gravity on the planet due to the human. Is it more than or less than? Okay, I'll just write it out, you know.
Oh, sorry.
Okay, hello. Okay, I'm so sorry. Yeah. So the force is the same, but it's just that the mass of the Earth is much bigger, much more than the mass of the human. So therefore, the acceleration of the human is a lot more than the Earth. And the formula is just for conceptualization. It's not, you don't have to memorize it. It's just for you to understand. And they might ask you questions about like what I just asked, like is the force of gravity on the Earth, whatever, blah, blah, blah. They might ask you that because they want you to know the concept. Okay, so guys get it? Okay. Uh which question? Okay, I'll just like type it out in the chat. That'd be so chat. Okay, this one's for you to think about. So that's all because I look here I have no more time. But if you guys want to ask questions, you can ask now. Or you can just like DM me, because yeah, any questions you might have. It's supposed to be 1 hour, yeah. Yeah, any questions on physics you can ask me as well. I can probably answer. Oh yes, you can scan the QR code to give me feedback. Please be nice, guys. I tried my best.